going to show you a different type of factoring. It's called factoring by grouping. The first thing I want to do is just quickly do a review of the distributive property because that's what we're going to be using. If I had, for example, just this very basic review of the distributive property, right? I could take something, multiply it times both of these, multiply the A times the B, multiply the B times the C, and I could rewrite it this way. However, this is a simple version. We've done this kind of distributive property before. But think about what we could do if I looked at this part and I wanted to factor it. Think about what we could do. We could take out what's the same in both, and that would be the A, right? It's the same in both. What I'm going to be asking you to look for is something that's the same in both parts. Now, what if A, instead of just being a single variable, what if it was another binomial, for example? If A was x plus 2, and now again, times B plus C, right? It gets a little confusing if we do that. What I've got here is now I've got the x plus 2, I'm just replacing the A, times that B. I would take this whole thing times B, and I could take that whole x plus 2 times C. Now this is not exactly what we're going to be doing today. I just wanted to show you an example of the distributive property that I think you'll be able to follow so that when we get to today's factoring, hopefully it will make some sense. Right, so does this make sense what I did? I took the A times B, there it is, A times C, there it is. I could take something bigger for A times B, there it is, something bigger times C. Okay so far? Okay, notice here, again, what's the same in both? This binomial is the same. So notice also that the things that it's being multiplied by, the B and the C, were originally together in one parentheses. Here, because we did the distributive property, they've been separated out. Here, they are reunited. And it feels so good. We're going to sing that song in a minute. Now, let me show you an example. Shh, we're not singing yet. Let me show you an example of the kinds of problems you're going to see. First, the directions will say to factor. So the first type of problem you'll see is where it looks kind of like what we just did. For example, 5 times x plus y plus w times x plus y. Again, notice what's the same in both. The binomial x plus y appears in both terms. If I want to factor this, and I realize, hey, that was the same in both. Look it up here. This was the same in both. Well, it's one of the binomials. So if it's the same in both, I keep it. Hey, that's one of the binomials. Now, look at these. Look at what happened with our B and C. They were separate. Originally, they had been back in one binomial together. What do you think I'm going to do with these? Reunite them. Leanna?
Put them in a group.
Yeah, I'm going to put them into a little group. Whatever's the same, well, that's one of the factors. If they had been distributed already, we can put them back together. Vincent?
Does it matter where the group is?
You mean like could you have it in the other order?
Yes.
Yes, you can have x plus y first and then 5 plus w. You can multiply in any order, so these two binomials could be flip-flopped. Now, this isn't quite factoring yet. This is actually leading up to factoring. I'm going to do one more that's like this. One or two more, I take that back. Let's do one more. M times m plus 4n minus m plus 4n. Now again, if we are looking for what's the same, m plus 4n, oh, that's the same. So that means that's going to be part of my answer. That is one of the factors. Now, I'm putting, again, this one in front. It could go behind. That would be fine. What am I reuniting here, though? Here we've got to be a little careful on the second part. Right here we reunited the 5 and the w. Oh, they were both being multiplied by that binomial. Let's put them together to show that they're both being multiplied. Here, what are the two things being multiplied? Jaden?
M and the
What?
minus. Oh,
Minus, good, okay, so we have to keep the minus. What invisible number do I never show but is there?
1.
1. How many of these do I have? I have 1. We don't show the 1. So if there is a missing number like that, it's actually that invisible 1 that we normally don't write. I reunited them, even though I couldn't even see the 1. It does feel so good, doesn't it?
Yes.
It does. Now, one more like this. I need to show you one more like this before we get into the actual factoring by grouping that matches with our title. One more. 5 times a minus 3 minus 2a times 3 minus a. In these first two examples that I did in green, remember that we had, you don't have to go to put this in your notes, I'm just going to go back and circle. These were exactly the same, right? These were exactly the same. So I could just put them straight in there. So here's my question first. Are these two exactly the same? No, they're exact opposites, in fact. Positive a, negative a. Negative 3, positive 3. They are exact opposites. They're close to being the same, but they're not the same. So there is a little trick we can use. We want to make these the same. So we are going to multiply one of them. Now, it doesn't really matter which one. I'm going to do this one, though, because I like my variable to be positive. We are going to multiply by negative 1. It's a kind of complicated explanation why we're allowed to do this. If you really want to know, come back and see me after we get started today, and I can try to explain it. But it's kind of a complicated idea. I might not even explain it very well, but I can try if you want to know. Just know that if they're exact opposite, they have to be exact opposites. Again, positive, negative, negative, positive, exact opposites. We can multiply one of them by negative 1. Now let's think about what happens if we do that. The numbers won't change, but the signs will. If I multiply 3 times negative 1, I get negative 3. If I multiply negative a times negative 1, it becomes positive. Negative times negative becomes a positive. So it changes this. Negative times negative, positive a. Positive times negative 1, negative 3. It changes it to match the other one. Okay? Now, I'm not going to give you too many like this, but you do need to be familiar with this because it will show up once in a while. Now that I've done that, it matches. What am I going to reunite for my other? Oh, I'm sorry, one other thing. When I multiplied by negative 1, sorry, I missed one little step. What we're doing is we're multiplying this whole thing by negative 1. Not just what's in the parentheses. So it changes the parentheses so that they're both the same. But it also changes this to become a positive, right? Negative 2a times negative 1 becomes positive 2a. What's going to go with, reunited with the 2a that's now positive? Jaylene? The 5. It does. When it's reunited, it feels so good. Okay. Did I show you guys that song last year, by the way? I'll have to try to find it. It's a 1970 song that reunited, and it feels so good. It's pretty awesome in like a 70s disco kind of way. All right, now, guys. Shh, shh, shh. We're not doing it yet. Shh. Now, here's where we're going with this. We're going to do a different type of factoring, where it's not a trinomial that you can do reverse FOIL on. It is going to be a polynomial with 4 terms. So first of all, notice it's not a trinomial, so we can't do reverse FOIL. 2ab minus 6ac plus 3b minus 9c. Now, at the beginning of chapter 5, we looked at some problems where we factored. For example, if it was just this, and we factored by saying, what's in common in both that I could factor out? If I looked at just these two, what's in common to both of them that I could factor or divide out? CJ?
A.
Okay, an A. What else? What about the numbers? Brian? Yeah, they both divide by 2 and they both divide by A. Could I divide these by 2 and by A?
No.
Right? These next two pieces wouldn't divide by. So if I look at this as all 4, is there anything that all 4 have in common that I could divide out of all 4 pieces? Not really. I see somebody saying we could divide 1, but of course dividing by 1 doesn't change anything. They're all the same. So if dividing by 1 is all we can do, then guess what? We can't do anything. So factoring by grouping, right? Remember our title, by grouping, if you have 4 terms and there's nothing that can divide out of all of them, we are going to put them into 2 separate groups. The first 2 and the second 2. And you should be able to do all these by just taking the first 2 and the second 2. You don't have to reorder them. Now, let's treat each one separately. We already talked about this first half. You guys said we could factor out a 2 and an A. So let's do that. If I factor out a 2 and an A, remember that what we're going to do, and this goes back to the beginning of chapter 5, we're going to divide both pieces by this. But that 2A is one of my factors, and what else is left over is my second factor. Right? So we'll ignore this part. This should be, going back to, I think it was lesson 5.3. So the 2A that I can divide out of both is my first factor. When I divide it, 2 divided by 2 is 1. A divided by A cancels out. So really I could cancel the 2's and the A's. I'm left with a B. Let's do the next piece. Negative divided by positive makes a negative. 6 divided by 2 makes 3. A and A I could cancel out. And it leaves C. Everybody with me on that factoring? Okay, now we'll do the second part. Just looking at these 2 pieces, ignoring the first half. If this is my only group, what can I factor out of both 3B and 9C? Carissa?
3.
Good, just a 3, not a B or a C because it's not in both. Remember, this is my first factor. I put a plus because the 3 I'm factoring out is positive. Okay, so that's where the plus comes from. Now, what's left when I divide is my second factor. If I divide 3B by 3, the 3 and the 3 could cancel out, leaving just the B. Negative divided by a positive makes a negative. 9 divided by 3 is 3. The C, I can't cancel. There's nothing to cancel it with. Oh, look what happened. These are exactly the same. Oh, like what we started with. If they are exactly the same, we know they are one of our factors. What else do I need to do with the 2A and the 3? Sing it to me. Reunited. Feels so good. All right. Shh. Good. And nice singing too. All right. Notice we started where it was already in this form. When we are really factoring by grouping, we have our 2 groups. Guys, if you do it right, you should get exactly the same thing. Or, the worst case scenario, they're exact opposites, and you have to do a -1 trick on one half of it. I'll show you one of those. Let's do one more, factoring by grouping all the way through. AB, last one, minus 2B plus AC minus 2C. AB minus 2B plus AC minus 2C. I immediately see there's nothing I can factor out of all 4 terms, so I'm going to factor by grouping. If I just look at the first half, what can I factor out of AB and minus 2B? Vincent? Just a B. Now remember that B is my first factor. Let's see what's left over. We divide both of them. B divided by B would cancel out, leaving just the A. Second piece, B divided by B cancels out, leaving the minus 2. What can I cancel out of both pieces here? The second half, AC minus 2C. I can divide them both by C. The C is my second piece. C divided by C leaves just A, C divided by C leaves a minus 2. Once again, we see that we have the exact same thing, A minus 2. That's the goal. If you don't get that, or at least get exact opposites for the -1 trick, then you made a mistake, you gotta go back. A minus 2, and I reunite B plus C. This is my factoring. How could you test, before we sing it, how could you test this to see if this, your answer, is the factored version of what we started with? Any ideas how we could test it? Okay? Okay, FOIL. First, B times A. Oh yeah, there it is, AB. Outer, -2B. Oh, there it is. Inner, A times C. There it is. Last, C times -2, -2C. If you're not sure if you got it right, FOIL it. This is a different result because it's 4 terms, but that's all you have to do.